The deep sea is not just another part of our planet. It is Earth's last true frontier, a silent, crushing, lightless world that feels more alien than Mars. We have mapped the surface of the moon in greater detail than the ocean floor beneath our own feet. And yet, down there, in that eternal darkness, giants rule. This phenomenon has a name: deep sea gigantism. In the freezing waters near Antarctica lives the colossal squid, heavier than a grand piano, armed with rotating hooks and eyes the size of dinner plates. Nearby drifts the seven-armed octopus, Halifron atlanticus, ghost-like and massive. The lion's mane jellyfish trails tentacles longer than a blue whale. Giant sea spiders stretch across the seabed like creatures pulled from nightmares. And in the Arctic depths, the ancient Greenland shark moves through time itself. But why? Why would life grow enormous in a place so hostile, so starved of light and warmth? At the surface, survival is speed. The blue whale became untouchable by becoming enormous, 190 tons of living gravity. Nothing hunts it because almost nothing can. But most creatures cannot rely on sheer size alone. In the sunlit waters, life is panic in motion. Swordfish slice through the sea like living missiles. Blue-tune tuna are built like torpedoes. Even flying fish erupt from the ocean, not to soar, but to escape. And beneath them all, the great white shark rises from the glare, turning sunlight into camouflage before striking. Up here, hesitation means death. But light only travels so far. As we descend into the twilight zone, the blue fades into gray and then into black. Hunting becomes nearly impossible. Vision fails, sound distorts, shadows deceive. So evolution builds monsters. The giant squid evolved the largest eyes in the animal kingdom, not to see sunlight, but to detect the faintest flicker of bioluminescence. For centuries, sailors believed they were myths. We only saw them when storms dragged their bodies ashore. Then, in 2004, we finally saw one alive, nearly 43 feet long, a living relic of legend. Deeper still lives the colossal squid of Antarctica, heavier, bulkier, armed with hooks that rotate like mechanical claws, a predator forged for pressure and patience. But as we sink farther, something changes. Speed disappears. Violence slows. In the Arctic depths, over 6,500 feet below the ice, swims the Greenland shark, a titan weighing over a ton. Yet it drifts at less than 1 mile per hour. Its heart beats slowly, its metabolism barely whispers. It does not chase prey, it waits. When a whale dies and sinks, a whale fall, it becomes a banquet lasting years. The Greenland shark can survive on a single massive meal for astonishing stretches of time. And here is the haunting part. Some of these sharks are nearly 400 years old. Alive today are individuals born before the Great Fire of London, before the Mayflower crossed the Atlantic. They are living history. Many of them are blind. A parasitic crustacean attaches to their eyes, slowly consuming the tissue. Yet they continue drifting through the dark, guided only by scent. Blind, ancient, unhurried. They have conquered time by slowing it down. In the open ocean, where there's no floor and nowhere to hide, life becomes illusion. The oarfish hangs vertically like a silver ribbon, inspiring sea serpent myths. Giant siphonophores stretch like drifting chains, not one creature, but thousands working as one. And still, we haven't reached the bottom. When we finally touch the seafloor, the drifting stops and the crawling begins. Giant isopods, pill bugs the size of small dogs, march across the mud. Japanese spider crabs extend legs spanning over 4 meters, moving like mechanical walkers in a forgotten factory of the deep. Sea pigs graze in herds. Tripod fish stand motionless for years, waiting for food to drift by. Why so large? Because in the deep sea, energy is everything. Small bodies burn fuel too quickly. They starve between meals. Large bodies act like slow-draining batteries. A giant squid weighing half a ton may burn shockingly few calories per day. They are not lazy, they are efficient. And in the polar seas, gigantism reaches another level. Cold water holds more oxygen. According to Bergman's rule and the oxygen temperature hypothesis, this abundance removes biological limits on size. Antarctic sea spiders grow as wide as dinner plates. Some absorb oxygen directly through their legs. The Antarctic sun star can grow 50 arms, not 5, forming a living trap across the seafloor. Even the lion's mane jellyfish stretches tentacles longer than 100 feet. But here's what makes it unsettling. In freezing water, everything moves slowly. Water thickens, muscles stiffen. You would see a predator approaching long before it reached you, but you wouldn't be able to escape. Now imagine diving deeper into the abyss. At 13,000 feet, pressure would crush a human instantly. At 20,000 feet, it would flatten steel like paper. Yet life adapts. Creatures abandon rigid bones for soft, gelatinous bodies that cannot be compressed. Red pigmentation renders them invisible because red light never reaches these depths. The fangtooth fish carries teeth too large for its mouth. The gulper eel unhinges its jaw to swallow prey nearly its own size. The Dumbo octopus flaps ear-like fins in lonely silence. And then there is the big-fin squid, trailing impossibly long arms bent at eerie angles, hovering like something that was never meant to exist on Earth. At nearly 36,000 feet in the Challenger Deep of the Mariana Trench, pressure becomes almost unimaginable. Yet the Mariana snailfish survives. Its secret lies in chemistry. Its cells are filled with TMAO, a molecule that stabilizes proteins against crushing pressure. It doesn't fight the environment, it becomes part of it. Down here, even giants exist. The amphipod, Alicella gigantea, grows to the size of a guinea pig, feeding on debris from the world above. And at the trench floor, enormous single-celled organisms called xenophyophores spread across the sediment like alien carpets, absorbing heavy metals and thriving where almost nothing else can. Life does not just survive at the bottom of the world, it dominates it. But this ancient stability is breaking. Marine snow, once harmless organic debris, now falls as a blizzard of microplastics. The deep ocean is warming. Warm water holds less oxygen. The very condition that allowed gigantism to evolve is disappearing. For creatures built for cold, oxygen-rich stability, warming is not an inconvenience, it is suffocation. The giants that survived crushing pressure for millions of years may not survive us. We often imagine the deep ocean as distant and untouchable, but our fingerprints are already there, settling quietly into trenches we have barely explored. We are the first generation to witness these titans in their true habitat, and we may be the last with the power to protect them. The deep sea is not empty, it is alive, with patience, endurance, and ancient power, and it is watching. If this journey into the abyss changed how you see our planet, subscribe to Science Uncovered and join us as we continue exploring the hidden worlds beneath our feet. Tell me in the comments which deep-sea giant surprised you the most.